everyone. We're the Automated JIT Debugging Agent team. There's just two students on this team, myself and Qasim, but our mentors were Filip and Rahil. Yeah, we worked on this debugging agent. So to give a little bit of recap as to what the kind of context of our work was, we kind of worked around this thing called JIT compiling, which is part of the JVM. And what it is essentially a way to make running your code more efficient by finding chunks of code that run often and then compiling those code chunks specifically. The way it works, next slide. The way it works is that usually Java bytecode is just interpreted, but interpreting doesn't allow for like optimization or anything. So if there's a chunk of code that runs often, it might be worthwhile to take the time to compile it and apply the optimizations that we want to apply, and then we'll run that compiled code instead of just interpreting the code every time. This process is non-deterministic, which means whenever you run a process, you won't really know what code is going to be compiled. And you can't like guess ahead of time which code and how it will be compiled, like the process and which optimizations will be applied. So it's kind of just this random thing that happens every time. This can be a problem when there's a bug in this compiler, because if it compiles code incorrectly and then you find your code isn't working properly, you won't be able to find it very easily because the next time you run it, it might compile it completely differently. You won't see the same bug. So it's incredibly complicated and hard to find some problem you have if it comes from this JIT compiler. So this is where our agent comes in hand.
So a little bit of background to our debug agent. The purpose of this tool is to find JIT compiled methods that are responsible for a test failure and to assist developers in finding the exact faulty code that results in the error. Some key features that existed before we came on was that a developer was able to trigger the debug agent by manually hacking the JVM process by changing a line to trigger it. And how it works is it recompiles methods individually to find the failing method, and then it recompiles using individual optimization to find the optimization that causes the failure. And what we accomplished this semester was we tried to make this tool more robust. And we did this by analyzing testing frameworks to prevent false positives from triggering the agent. And we use this to improve the mechanism that triggers the debug agent. We also generated diagnostic data to help pinpoint the problematic code, automated the process of enabling the tool using ASM, and added synchronization for multi-threaded tests. So what I worked on was the first two things, preventing the agent for triggering for false positives and generating diagnostic data, also synchronization for multi-threaded tests. So a little bit about the first thing I worked on. Previously, our agent would be unable to handle test cases where an exception was expected. And then this would cause the agent to run in tests where you would be expecting like a null pointer exception to be thrown. It would still trigger the agent. The solution that we went with was we analyzed how test frameworks handled exceptions, generated trace logs, found a place to inject code to store reference to these expected exceptions, and improve the mechanism for triggering the debug agent to ensure that these false positives were ignored. And the second feature was generating diagnostic data. Previously, our agent would only print out which method and optimization contained the error. The developer would still have to go ahead and manually generate the JIT dump logs to pinpoint the problematic code. The solution that we went with was to modify the agent to generate good and bad logs. So before the error occurs and after. And this would allow the developer to have easier access to the logs to compare the compiled code.
Yeah, so then what I worked on was, as Qasim mentioned, we didn't really have a way of actually running our agent at all. The only way we could do it was by manually going into like base Java files and changing some lines of code to allow our agent to be triggered. So we had to find a way around that and make it easier for us to run our agent. So the way we did this was there's this tool we use called ASM. And essentially what it is, it's a way for you to take code that's already been loaded into the JVM. So it's already been like compiled into bytecode and it's been put into the JVM. And then now it allows you to make changes by going through that bytecode and kind of making little tweaks and then reloading that class once it's already in the process. So that allows us to kind of make the same changes we were manually hacking in, but to be able to do it through our agent. So an example would be like if in like the Java base file and like the method class, which is such like a fundamental class of Java, if there's a line that says method.invoke, we'd want to use this ASM thing to find the bytecode of that and then alter it to instead call our own debug agent.invoke. Once I'd written the code that would allow that to happen, we turned it into an actual Java agent. And so the way it would work would be if you're running your code using like the Java command and you find it produces an error, all you have to do now is to type in the Java agent option alongside the command and include my agent jar, and then it will run the agent automatically.
Okay, and we have a demo video showcasing how the agent works. I'll just start over. Oh. So here you can see without the agent, the test framework only returns which method the exception was thrown in. And this isn't that helpful for figuring out where the issue is and for debugging. And here you can see that when our agent is run, it prints out like which first prints out which method caused the issue, and then which optimization. So here in the logs, you can see that log opt index 65 is the potential culprit, and we also generated two logs, like one good log, one bad log, that the developer can go ahead and then here we can see what which code caused the issue. And then in this example, this was a bug that was added in on purpose for testing purposes. And it was optimization index 65, which made this pretty like straightforward to figure out where the bug was. And that's basically how the tool works.
Yeah, so obviously it's not the prettiest looking thing, but it is very useful. So what we weren't able to get to work on this semester, but we hope to be added at some point in the future. First, we don't handle many different types of errors. We only handle like null pointer exceptions. Like for example, seg fault wouldn't cause our agent to run. So we'd want that to be changed. And then there's another type of compiling called AOT compiling ahead of time, which has a similar process, which could also have bugs. Our agent doesn't cover that right now, so we'd like to expand our agent to also cover AOT compiling. And then we also right now only work with JUnit. So if you're running tests using JUnit, it will work, but if you run with testng, you might have some kind of weird behavior like false positives and stuff. But yeah.
Thank you for your time, and you guys have any questions?